So I'm sharing the screen now.
Yeah.
So I have two exclusive presentation actually in the thing, and this basically from waste to green energy. So waste to green energy, when we talk about this particular subject, we cannot talk exclusive of what I should say, carbon footprint mitigation, and also the climatic resilience. The climate resilience should be a part of this particular thing. And so I take this from what is called the Vedic sayings, 3,500 years back to right now for 2020, when we are reinventing the Vedic tradition, and in terms of the new education policy, NEP 2020. So this is going to be the thing. And here I use the word waste and green energy, which really, have no meaning, right? And saga of Bain to Boon. So it's a story of Bain to Boon. So Bain in Kannada, of course, Shapa, and Boon means Vara. So please note that it's a curse or it's a kind of a divine gift from God. So please note that energy cannot be a curse. Energy can never be a curse because it's always existed. It is existing. It is going to exist, and there is no kind of destruction of energy. The total energy remains the same in the cosmos. And when we say this, what is this particular green energy, or what is that it is ungreen energy? It is really having no meaning. So with that concept, I just start my presentation, and I'm showing you the first slide where you see something. All of you, please observe carefully. This is a kind of a a structure, correct? Whatever you see here is belonging to the Western power from Western Australia, so near Perth or so, right? And please note that 30 to 40% of the power needs of the Western Australia is met with this particular plant. So using the waste. So please note that it doesn't look like that. So that means that there's no waste or whatever it is. So it's all green energy. So you can make it so green as this first slide. So that itself is the the beginning and end of my presentation, right? And we can always make this entire world so divine, right? And there cannot be any waste, like Dr. Kupekaran has said. So before I start, I just remember the hymn that was dedicated at my national college, right? Every day we used to sing this. Purnasya Purnamidam Purnat Purnam Udachyate Purnasya Purnamadhaya Purnamevavashishyate. So always there's a fullness, always fullness existed. There is fullness of energy, and energy only was never created, and it is never to be destroyed. It cannot be destroyed. It can be just transformed. It is unmanifest. So when it becomes manifest, right, we are going to be talking about the different states of matter, namely the Panchabhutas. So please note that the basic energy is not to be seen. You cannot say that I can see this energy or whatever it is, but I can always experience. If you want to experience electrical energy, you have to put your hand into the socket, then you will understand there's a shock. So like that. So please note that this is the basic thing that I would like to remind all of us here. So next slide, please, Modi. So please note that when we talk about this energy, so going back
maybe
to
you can go for full presentation mode. Your slides,
yes.
yes. Yeah.
Yes. So now, if you are talking about this energy, so what does the Titiri school of Yajurveda, Taittiriya Upanishad was dedicated for this. Titiri school of Yajurveda, Titiri Maharshi, 230 BC, he talks about energy, right? of 5 great energy elements like the Akasha, Agni, Vayu, Prithvi, and Jala Tattva. So all these phases, what you call this is the water phase and the and the gaseous phase, and all these things have already been enunciated, the fire and all this, correct? And it can only be present in these 5 forms, and then it has to be, circuitously rotated into that or a combination of that. So then we have been talking in this particular seminar about what is called the green energy. That is, what is this green energy we are talking about? Actually speaking, the green energy, right, is really difficult to have a definition of it. But what I just understand, right, green energy could be the spin-off energy, right, from the IGDA waste. IGDA waste is, that industrial waste, that's commercial establishment waste, domestic waste, and agricultural activity waste. So all these wastes is called ICDA waste. And these ICDA wastes are basically giving, some kind of a spin-off energy. Spin-off energy is going to be there. And this spin-off energy could be, again, of different types. You have to understand this. So my presentation today is going to be just, highlighting on these aspects. And, see, my students are there, right? Around 15 PhDs I have given in these areas. And there is no point in telling all these things in a 1.5 year our presentation here, because it will be too boring. So I just want to go to the fundamentals, the foundation of it, right, and how our research activities have been formulated. And then I will examine its kind of thing. So one is the conserved energy. See, please note that the green energy would itself be a conserved energy. So if you are going to just say, for example, wash your hand, and if you just minimize the content of water that you use it for washing your hand, that itself is conserving energy. So it may not be really realized in terms of this. So energy is conserved by the best practices, of course, right, in our lives. And also the engineered conservation of energy could also happen. The chemical engineers know about this, correct? And in the thermal power plants, correct? So you can really, conserve energy and use it for even right sintering and other aspects. So my students have worked on right for the PhD on this. And the conserved energy, and of course the donor energy. So energy, if it is in excess, could be donated to some other activities called the donor energy. And of course the classified energy. So energy again could be classified into the different phases, like the Akash, that is the the space. Then space also, you have the Gatakash, and which is a confined space, and of course unlimited space as Bahyakash. And Gatakash and Bahyakash are again the two kind of different kind of domains, which were not which were known earlier during the Vedic period, but up to 1905 it was not known, till one great person, correct, Satyendranath Bose, he wrote a letter to Albert Einstein that E is equal to mc square is wrong. Then he was removed from the Jadavpur University, and he had to go to Dhaka, University of Dhaka, where the British professors encouraged him to write a letter to Albert Einstein. And he writes a letter telling that there is a particle without mass. So please note that this kind of particle without mass goes to, to be proved almost near in 1968 by Higgs. And it came to be called the Higgs boson. And the Higgs boson was discovered in 2015, which is the new realm of mechanics, is called the realm of mechanics of God particle. So please note that we are now moving from mechanics of Newton to the mechanics of relativity, that is the Albert Einstein. And now in 2015 and onwards, we are talking about what is called the God particle mechanics. So please note that this is particle without mass, which I think is unbelievable today. So we have to change all our engineering systems accordingly, and it is really to be defined in a new norm. And please note that we have also the recycled and the transformed energy. The recycled, of course, right, you know that you have one condition, it exists. So into some other condition, I have to bring it, then I have to recycle it. So what you call the recycling happens for a particular utilization or use, and it's the transformed energy. And of course, destructive energy, as you know, anoraniyan mahato mahiyan, it has been said. So as you go further, divide the material, right, you get destructive energy of the atom. So this was told in the Vedas. So anoraniyan mahato mahiyan, you need not go like the mountains, right, of the Himalayas. If you also divide, you get the energy. So these are the things which right have to be understood as far as the energy is concerned. And about the green energy is concerned is about handling this manifest elements. So please note that the unmanifest energy, so handling of the manifest 5 great elements, either the same or the different combinations, is going to clear our doubts regarding green energy. And here again, when we are talking, so we have to understand that one, we generally call it the renewable or whatever it is. Say, for example, the solar energy, etc. So solar energy, right, is always there, the sun, right? But if it is not utilized, it is a waste energy. So again, so from waste to green energy, if you want to transform, so what happens is that as long as you don't utilize energy, it is a waste energy. So it is not that it's the energy from the waste only has to be told like the right, etc. That's of course, that's one way of expressing. And please note that the renewable definition has to be really understood in a much better methodology, right? So renewable energy. So even the waves, correct, in the sea, correct, we can draw energy from it. So as long as the waves are not harnessed, it is a waste energy of the sea. So please note that if it is harnessed, then it becomes a renewable energy. And of course, there is no what I should say, the spin off evil that is going to be caused by it, or the pollution or whatever it is. And even say, for example, the joke falls, right? If there's a lot of potential energy, right, is now converted right into kinetic energy, or if the falls is there. So what's happening there? So please note that if you simply keep it like that, it is not, it's a waste of energy. It's a waste. So if you just take it out from this, right, the mechanical energy and then the electrical energy, then it becomes quite a renewable thing, right? And please note that there are debates about this, that is the water energy, correct? So here, another thing that I have to say here is that the clean energy. See, if you just split the atom, H2O, you get 2 atoms of hydrogen. So you can always say is called the Brown's gas. The Brown is a scientist from Australia. So we worked on when I was in RV Engineering College, right, where I worked in 2000. We had a project called the TIFAC project, correct? HETP, that is a Hydrogen Economy Technology Program, which is called the George Bush Initiative. So we worked on this, and around 4.5 crores was given to us. And we also contributed around 4.5 crores to work on this Hydrogen Economy Technology Program. And I would rather say that so splitting this water and taking out the hydrogen, which is the cleanest form of energy, which doesn't contribute to pollution, was our research studies, correct? And please note that tomorrow is going to depend on the hydrogen as the clean energy. If somebody is not thinking about hydrogen as clean energy, then he will be into history. I think I can say clearly that is the kind, and particularly our chemical engineers should help us in this aspect of getting the hydrogen. But what happens is the cylinders are so big, the volume is nearly 30 times bigger than our LPG cylinders, or even 40 times. So how to handle that has been a problem. This is called one of the 15 challenges in the world right today, right? The hydrogen energy is one of the clean energy is one of the 15 challenges that exist in the world today. So Another aspect of it is the not manufactured or the harnessed energy. So if some energy is not manufactured and then if it is utilized, then it is a green energy. So please note that I will be talking about this. At least around 11 of my out of 15 students have got PhD in this subject of not manufactured energy, right? The harnessed energy. So how they have got right, and I will just discuss in the later this. So please note that to make things simple for you, right, is waste is basically from ICDA waste, correct? And as we think, and is from industries and of course commercial and of course all these agricultural activities and domestic activities. So when we are talking about this, and always right, we have to understand that this primordial classification is the organic waste and the inorganic waste. And you know that the Kupekaran was dealing with the organic waste, basically, correct? And please note that it's around 62 million tons per year of the right organic waste is right generated, but in India. But let me tell you that there's 30 million tons of fly ash only is produced in India. So this is almost half the organic waste that is produced in India is going to be fly ash. So please note that fly ash being an inorganic waste, how do you handle? This is a huge problem, and right, and things can be right. The solution can only be given by civil engineers because there is no other industry which can really, take it up except the civil engineering industry, right, which will honor this and which will take this as a resource. So therefore, by attributing the waste is a kind of a status as a resource, you immediately, bring it to the green energy domain. Whereas is an organic also is, you get a green energy domain, and also in the inorganic also you get a green energy domain, which we will address it in further. And of course, when you're talking about the organic part, and you have got the digested and the undigested, of course, right, and you require the bacterial intervention for this organic. And thanks to organic waste, so we have plenty of them, and we have the bacteria, which is Escherichia coli itself can degrade this one, because that's another advantage we have. And please note that this degradation can happen under certain controlled conditions. Then you call it technology of converting the organic waste, and all of that has been already talked about by Dr. Baswaya sir and other people, correct? And of course Kupekaran sir. And the digested one is the partially degraded organics. And of course this undigested one, of course you can have this for vermicomposting and other things, and you can add it with the other industrial waste like the dairy waste and other things, and you can just do the digestion process. But I would like to say that the material value, if you say NPK value, is very minimal. And please note that the city waste I'm talking about, the city organic waste, the solid waste, we have very poor NPK value. I think we are boasting too much on this, which is not correct at all. It is not correct that we can use this kind of a thing, with such a low value as 2.3 to 4.2 kg per tons, etc. And this doesn't really mean anything. So, but at the same time, so we have another domain also that is called the inorganic part of the waste. Correct. Inorganic part of the waste, of course, is coming from the mineral origin. Of course, the sand, silt, and all these minerals, and of course, slightly affected by the organisms. The organisms have actually a very little kind of play, or unless you design an organism for consuming it, you cannot have, unless you make a gold bacteria, you cannot just take out gold. So unless there's a specialized kind of a recombinant DNA technology, say you cannot just use it. So what we'll have to do, because it is a humongous kind of a volume of these waste, that are being generated in the country, which cannot be neglected. And of course, you cannot just have, say, for example, there is a school of thought that the energy, right, when we are talking about the thermal power plant should be banned. See, you can never ban the thermal power plants, let me tell you, because all the other countries have, of course, been right. Maybe right, they may close it, but there are two important countries, correct, which cannot do away with that. That is India and Australia. So the entire Indian subcontinent is in a sedimentary rock domain. So where this entire subcontinent is having coal deposits for the next 400 years. So we are so rich, even if the Gulf goes away, right, not able to give the black gold. So we are able to survive for the next 400 years, which we have not tapped at all. That is the coal, correct, is next 400 years it can remain. Then the only second country that can have a similar kind of a situation is Australia. So these are the two countries which can use it. And definitely we have the coal dependency. And our coal is a bit sulfurous, right? And therefore there is a problem with that. If we can just, the chemical engineers can take out sulfur from this coal, then I think we can manage our pollution problem also in a better manner. So this is another challenge that we have in this country, correct? And coal, you cannot just say that I don't have. So in Karnataka itself, you have in Raichur thermal power plant, you have in Udupi, right? In the Ermaras, you have this Bellary plant. And I think, even smaller plants are available. And this coal burning cannot be prevented. And what happens if you burn the coal? So entire thing, this carbonaceous matter, right? Carbon dioxide, it escapes. So it's going to increase the carbon dioxide content in the atmosphere. So what happens is the climatic resilience is affected, of course, due to this. So we had to do something about it, and we'll come to do this, right? So once we say that waste, right, what happens? What is the waste part of it I'm discussing in a thermal power plant? So in a thermal power plant, so once you take it to 1600 degrees centigrade, right, what happens is that, of course, these particles, correct, especially silica and alumina, so will be almost hollow spherical particles. It becomes of 3 to 5 microns. And if it is 3 to 5 microns, it can escape into air. And it's escaping into air, right? And 3 to so 3 to 5 micron particles. And I think, can you mute it, sir? Yes. And of course, the fly ash can almost, fly into the air. And of course, it is in the form of SPM. So what is this fly ash, if it is escaping into air, is causing? So some people know that it is causing nothing. But what happens is, along with that, CO2 is going. Carbon dioxide is also going. So please note that carbon dioxide is also not doing any problem. So please note that carbon dioxide also with the SPM, that is the suspended particulate matter, so and going, and to the outer layers of the atmosphere and making a layer. So what it makes it is going to be a glassy surface, and the energy that's coming from the sun is totally trapped. And of course, this increase in temperature. Increase in temperature, of course, is going to cause the global warming and therefore global alarming. And then the sea levels rise because the polar ice caps will melt, and there is going to be pralaya, right? And of course, you know that the sea is rising. So it is estimated that Australia will be wiped out. Australia is going to be wiped out. So this is a prophecy. It's not a prophecy. It's a scientific revelation. I'm telling you. So tomorrow you can say that there's nothing called Australia, and nothing called Bangladesh, and nothing called Central London. So these are the most affected thing because of the fly ash problem. So, and also carbon dioxide problem. So if they're just excluding the inorganic waste and the fly ash problem and the carbon dioxide problem, which is very extensive in causing the thermal increase, correct, is what's happening. So we wanted it to be at 0.83 degrees centigrade by 2003, but it has now gone beyond it. So 1.5 degrees centigrade, we have already got it. By 2020 itself, it is like this. And if it is 2100, it should be limited to 1.75 degrees centigrade. Otherwise, we will have disasters coming for us. So please note that treating the inorganic waste, right, at least 11 PhDs I have given in this area. So please note that you have to handle it in a proper manner. How do you handle it is right, the subject matter for a civil engineer, right, basically because we have to use it as a repository, correct, as a repository in cementitious matrix composites or as a supplementary cementitious material, because fortunately for us, it is acting like cement. So this is one thing that is there. Then the GGBFS. GGBFS, of course, is another kind of a nuisance for the steel plants. And but if you really ground granulate it, and ground granulated blast furnace slag is going to be having a lot of value. And of course, you can make the cement bag, right? I just had suggested for my hostel here, hostel blocks, where the people said, sir, cement bag has gone to 600 rupees per bag. What can I do? I said, use GGBFS. Why do you go for this? Then they utilized this opportunity because what I had suggested from my research work, and when say use GGBFS was costing around 200 rupees. That's almost a transportation cost, correct, per bag. So they could really save, this thing. So please note that almost 1/3 when it is available. So please note that this GGBFS being a waste material, right? You are utilizing it for a particular construction that I showed in the first slide. Then what is the thing that you are going to lose? So please note that it becomes a repository in a new construction or a modern construction. And please note that this kind of a reuse of the kind of material itself is a very challenging task. But please note that civil engineer is required for this. There's a lot of, it is not simple like that, because if you are using these are called non-standard materials. This fly ash, GGBFS, and C&D waste, that is construction and demolition waste, and you have plenty of that now. So last year, there's a ministry for construction and demolition waste has been created in the central government, and there's a minister for the state minister also for C&D waste, because there's a humongous amount of C&D waste that's generated, and it is simply being dumped into the open dumps, and not this thing. So even the corporation of the city of Bangalore has allotted a precious land of 2 acres that's not to be given to anybody at the Yashwantpur, right? In Yashwantpur, they have allotted this to convert C&D waste into construction materials, correct? And please note that this is the only way that you talk about the inorganic waste is, right, 300 lakh tons of it, only the fly ash itself, and about 100 lakh tons of the other waste. That's around 400 to 500 lakh tons per year, right? It is impossible to just, just leave it like that. So you cannot biodegrade also. You cannot take out gas or anything out of this also. It is inorganic. So what do you do? It's a civil engineer's business. But when the civil engineer business, right, is going to be with a standard material, then we have already tested it, and we have our courses designed for the RCC and steel, and all these courses, of course, are designed for standard materials, and standard ports are existing. Please note that. But whenever I use this kind of a waste material, it is called a non-standard material, and the art of research potential is there. And I would declare that civil engineers, therefore, have to be careful, because you can kill 5 lakh people, 10 lakh people like that at a shot using these materials. This material can kill, right, 50 lakh people at a shot, correct, by using this in your dams or whatever structures. Therefore, you require to know about its behavior, correct? And you have to create what are called the phenomenological models, which I myself worked with Dr. T.S. Nagaraj of Indian Institute of Science. So we have done a lot of right work earlier. And of course, then we had the opportunity, right, to work on a particular kind of an issue that there's 100% utilization of this. So earlier we were afraid and we used to do 20% utilization, etc. Then we call this as blended composites, blended cement or something that we used to have. And then we tried around 50% of this kind of materials. Then it's called the high volume fly ash concretes. So we could create high volume fly ash concretes. So we could take it 50% of them. Now, so we ventured later into 100% of utilization of this fly ash, which is called the geopolymer. When we use this particular terminology, geopolymer, so it was contested because polymers means, the chemical engineers understand in a different manner, whereas we are talking here inorganic silica alumina chains. Then how do you call it a polymer? Then there was a lot of debate. Then I had to go to Indian Institute of Science. Then I had to take a permission from them that yes, you can call this also as polymers. Then we called it geopolymers. It's nothing to do with the polymers that you people are talking about. So please note that this geopolymer concrete is another kind of an innovation that has given rise to the handling of the inorganic waste and keeping on telling the research results of this and other things is meaningless. I had to just open up the thing. So handling of fly ash waste, GGBFS and CND waste is tremendously increasing the of course, stress on our thing, the Indian economy or even the world economy, in fact. And so when we were not utilizing this earlier because we had no codal provisions. So even Dr. Kasturi Rangan asked me, see, we do not have the codal provision at all, then how you are trying to use it? So the answer to that question is that when you don't have codal provisions, you have to go by the research and the phenomenological models. You have to create the phenomenological models and use the phenomenological models for utilization of these materials to have the factor of safety involved in it. So right now the standard materials give you a factor of safety of 7, even 7 times more than the load that is prescribed by the engineer. If you put any RCC building will not collapse, but we do not know about such kind of a factor of safety for these materials. So for that, there's a lot of research, of course, going on and in the country and abroad. And of course, there are people who have been, especially Dr. Rangan from Perth and Australia, who was earlier from Indian Institute of Science, who has been working on this. And earlier, a chemistry person actually discovered this geopolymer in 1968. So Joseph Davidovich, and please note that it is his invention that we have. And in the recent times, we have Dr. Rajmane. Dr. Rajmane is doing a lot of work on this geopolymer at the SRM University. He was the director of SERC, Structural Engineering Research Center at Taramani, Chennai. And of course, a lot of work he has done. And in fact, he is constructing a Jain temple near Hassan, using geopolymers, which is 100% utilization of fly ash. And there's no cement utilized in that, no cement utilized. So that means if you are not utilizing cement, what will happen? If you are not utilizing cement, so you require, for manufacture, if you manufacture a ton of cement, you know that 800 kg of carbon dioxide is getting into air. How it is not the mass balance. It is not the mass balance. Please note that the electricity utilized in the plant, is from thermal power plants. And the thermal power plants utilize coal burning. And the coal, if you are burning, then the fly ash, of course, is going to be there, generated, etc. So please note that, and also carbon dioxide is coming out. And that carbon dioxide is right, around, say for every ton of cement, the carbon dioxide is going to be 800 kg of carbon dioxide that is ingested into the atmosphere. As I rightly said, SPM plus CO2 is causing the global warming. So please note that this is one aspect of it which I wanted to say. Therefore, what is the solution? So the solution is the bulk utilization. The bulk utilization is not simply some laboratory thing like 10 grams, 8 grams you're dealing. It is nonsense. So when you talk about bulk utilization, only we can handle the civil engineers. So we require the bulk of this material. Say, for example, China wanted to take all our fly ash. They said, please give all your fly ash. We want to construct our highways. At that time, we were not knowing how to use it at all. So we gave it. Initially, we gave our fly ash and they made their fine roads in Chinese. They're really good technology, right? And after that, we understood that it is a loss of exchequer for us, and we started doing this ourselves. And again, there was a problem because we have got a fly ash called the Class F fly ash from Raichur, whereas in Neyveli Lignite Corporation, the fly ash is Class C fly ash. And the Class C fly ash has got its own kind of a right problem associated with it. When you use a Class C fly ash, correct, and even people do not know there is the different classes of fly ash. Simply they are talking, just lagao, put it. It doesn't happen that way. You have to understand the chemistry of it. So please note that the Class F fly ash, of course, has having less of calcium. So of course, you can use it directly. Whereas Class C fly ash is a dangerous one. So it's from Neyveli Lignite Corporation is coming. So where it's a highly calcinated, calcium content is more there. And obviously what we have to be careful is that the handling of this Class C fly ash is going to be another great problem for us. And if you are using Class C fly ash in our concretes, so you can expect a lot of problems. Like if you are using Class C fly ash in Jammu and Kashmir, so where there is cold temperatures that's prevailing, then what happens is that due to this freezing and thawing is going to be right affecting this kind of thing. And also there's going to be formation of the deleterious compounds. See, first, what civil engineers do is 21 days strength or 27 days strength, we just stipulate. And 27 days, for a standard material, it is all right, strength. And if you come to BMS Engineering College, they will give you a strength at 27 days, right? And it doesn't happen that way. In case of these kind of supplementary cementitious materials, what happens is 27 days, the strength is increasing, right? And 60 days is superbly increasing, and 90 days it becomes, like very, very, very strong. But after 90 days, right, nobody tests it. Nobody tests after 90 days. Then after 90 days, it is going to degrade itself and then becomes a Upitu kind of thing, concrete. Then the whole structure is going to collapse and lakhs of people will be dying because of nonsense, correct? And your bridges and this thing collapse will happen. So please note that why does it happen? So that happens because in case of the Neyveli fly ash, that is the Class C fly ash, what happens is that you have a late attack problem. Late attack, like a fits in the thing. The concrete has got a fits, correct? So up to 90 days, it's simply monotonically increasing. And after 90 days, it's coming down. And obviously, you have got the deleterious materials, right, that is coming. And this could be a lot of chemical engineering could help us, right, in understanding these deleterious materials. We got the thaumacides and the yttringites are formed. And these thaumacides and yttringites suddenly right formed. I can show you in the SEMs and other things. Our students have done it. And what happens is then the entire concrete becomes, like amorphous, and then your structure is going to collapse. So we have to be careful. It is not that, everyone can do lagav. I will use the supplementary cementitious material and then ward off this problem. So please note that this entire thing I'm talking about is harnessing the energy. It is all about harnessing the energy And please note that since we are utilizing a waste material as a resource, we are preventing cement being utilized. And if you are preventing cement being utilized, you are saving the energy that was required to manufacture that cement. And therefore, I have saved the money for manufacturing cement. That means these are not manufactured. These are spin-off materials. Those spin-off materials are called the zero energy materials. All these are called zero energy materials. So the way you understand about energy is totally different in as far as for a civil engineer is concerned, right? And you know that we, the chemical engineers, civil engineers, aerospace engineers, right, are called the brothers, or the three brothers: aerospace, civil, chemical, and mechanical, the four brothers. So we have the same perspective, but we differ a bit in certain aspects of it. Otherwise, there's this is called School of Engineering, could be combined. Chemical, civil, mechanical, and aerospace could be one, because we all study this. You also study momentum transfer, and we also study that and everything. And of course, therefore, what is the solution for energy, right, harnessing? It is the bulk utilization. So how does the energy is harnessed here? Because you are not utilizing the conventional materials like cement. And if you do not use conventional materials like cement, and if you use the supplementary cementitious materials like this, what will happen is that you are saving on manufacturing of this. Say I said 300 lakh tons of cement is manufactured, but 300 lakh tons of this supplementary cementitious materials are also coming. Then if you use this instead of that manufactured material, you can save on the electricity. And if you save on the electricity, you can save on the coal being burnt in the thermal power plants. And therefore, the energy saving is going to bring a good solution for the entire waste management system. So the topic is going to be right well served. And this is regarding the bulk utilization. So we had a bulk utilization conference in 2000 itself at Annamalai University. Annamalai University, where extensive work has been done by Dr. Thiruvengadachar, right? And at that time, the structural engineering department. And in fact, a road has been laid using purely Neyveli glassy fly ash from Annamalai, Chidambaram to Neyveli. Chidambaram to Neyveli, that road is there. Please go and see. That is not cement road, cement concrete road. Please understand, it is using Class C fly ash. It's a Class C fly ash road, the first time in the history, right, of India. Okay, so that is called the zero energy materials. We saved on the cost and also saved on pollution, and therefore zero energy materials are alternative construction. So when did this concept come? This concept came from one of the greatest scientists of Indian Institute of Science, Dr. Amulya Kumar Reddy. Dr. Amulya Kumar Reddy, he started the thinking on sustainable technologies in long back. And of course, then there were people who were enchanted with Dr. Amulya Kumar Reddy. That was Dr. K.S. Jagdish, sir. Dr. K.S. Jagdish was is an earthquake engineering man. Then he said, there is going to be more value if I just work on in the area of sustainable technology. And in fact, Dr. K.S. Jagdish did not work on earthquake engineering at all, because he was so much fascinated with the sustainable technologies. And then he started working on that. And the last and the only person who got PhD in earthquake engineering was Dr. Raghunath sir, Raghunath from BMS Engineering College. So please note that that was the thing. And even Raghunath and myself, so we had several opportunities to examine this energy aspects in soil stabilized blocks. So we just wanted to create more cement in a soil stabilized block. How do you do that? The cement is argillaceous material plus calcareous material. When you just have this argillaceous material plus calcareous material, what happens is a free lime is liberated, and the free lime has no value, right? It is going to cause a lot of trouble, it's mischievous. So if you add some more soil into that, so it's an argillaceous material, and of course press it under the optimum moisture content OMC, you can get what is called SSB, which is going to be right of high value, right? Even 4 megapascal, you can get the compression strength. And this kind of zero energy materials are also very attractive. And this was also promulgated by one of the great architects, Dr. Laurie Baker, a German architect who started, right, when he comes to India. He was fascinated by the Indian thinking and Mahatma Gandhi. Then he says that this is my country. He just settles in Thiruvananthapuram. So it came to be called the Laurie Baker Technologies, is using zero energy materials, and the alternative construction technologies, right, started coming up. And therefore, the waste handling has no more, a problem because of the utilization and because of ascribing this waste as a resource. And please note that I constructed my house using these kind of materials in 1990 near Gnanabharati, right? And when I constructed, then, right, what happened is I used quarry dust. And at that time, nobody used a quarry dust. Everyone used a river sand. Then when I used a quarry dust, then the quarry dust wala came to me and saluted me by touching my feet. I said, the Pollution Control Board has given me a stricture that if you don't take this quarry waste, we are going to fine you. Then, sir, you are taking all my quarry dust. So I thank you very much, sir, and you helped me. Then I used it for my building. And after he came sometime afterwards, and then he said, sir, I cannot give you free of cost, sir. One load I will give in 1990, I'm talking 400 rupees per load, I will charge you, correct? So please note that it became a resource, right? Until the time that I used, nobody used in Bangalore or anywhere in the country, correct? But when I just dared to use this, my family member said, what is this nonsense? He's experimenting on his own house. Like that, they commented. And even Dr. K. Subrao from Soil Mechanics, they said, what is this thing nonsense? Then again, our the president of our Grasim Industries, Dr. Kalgal sir, he's a BMS Engineering College student, correct? And he's the advisor now to the Ultratech. He came to my house and said, what is this, sir? You're doing like this and all this, correct? And you are using all the supplementary cementitious materials and soil stabilized block. You're not plastering and all this. So please note that you require some guts and you require some right faith in your own technologies and research. Otherwise, you cannot do this. See, this is one thing that I wanted to say is about zero energy materials. So please understand that zero energy material is not a thing to be used without the engineering knowledge. So only knowledgeable people will have to use it. I will tell you also, zero energy material was copied, right? The KS Jagdish technologies were copied by Karnataka Housing Board. In Yelahanka, they constructed houses. And after constructing the houses, in 1 or 2 months, then the houses, broke, and then they were almost dissipated. The houses got cracks, and then it was of no use, correct? Then the people came and asked, Dr. Jagdish, what is the thing? See, they have not taken my technology, they have not consulted me, etc. So consultancy, right, with a proper person is very important. Simply you say that in the book, Dr. K.S. Jagdish has written like this, therefore I am also doing like this, it is nonsense. ನೋಡಿ, ಕನ್ನಡದಲ್ಲಿ ಹೇಳ್ಬೇಕು ಅಂದ್ರೆ ಸಕ್ಕರೆ ಹೆಚ್ಚು ಮಾಡ್ಬೇಕಾದ್ರೆ ಅದಕ್ಕೆ ಪರಿಣಿತಿ ಬೇಕು. ಸಕ್ಕರೆ ಹೆಚ್ಚು ಎಲ್ಲರೂ ಮಾಡಕ್ಕಾಗಲ್ಲ. It is not possible to do the sugar cubes that you give it in Sankranti. Everybody cannot do this. Please note that you require knowledge, correct? We have people like in the BMS Engineering College itself, there are a lot of people working on this, correct? You know them. So, right, I can give this thing. And of course, the other elements, of course, you talk about is the Prithvi or the Prithvi Tattva. As I have already told you, right, this is nothing but the Prithvi Tattva. What I talked about is Prithvi Tattva, the energy enshrined in this called the green materials. And my dear friends, and the bulk utilization of this class F and class C fly ash is of a separate kind of a domain. So if somebody is using class F and doing something, do not copy it for class C. It will be a disaster. Construction and demolition waste is, I told you, has come very important in the since last year. C&D waste, right? The ministry itself is being created because that is the humongous problem it is creating. And now we have a 5-storied civil engineering block at Melbourne using geopolymer composites. There's no cement concrete. So no cement concrete used means, you're using all this fly ash and other things for a geopolymer. So that means that it's a zero energy material. So you are not investing on any energy there. So it's a zero energy material. It's a beautiful block. I will show you the photo of this. And then you have got one thing that we worked, this is one on geopolymer. We worked with Dr. T.S. Nagaraj of Indian Institute of Science. I brought him after his retirement to RV Engineering College and started a research center, what is called, Alternative Technology Center, right, at RV College. And I also, gave this to one of my research scholars. We got fortunately for me, I got support from DST project, and I went to IIT Delhi also, and also Punjab Engineering College, right, where Kalpana Chawla studied. So where that great IIT professors, I still remember IIT Roorkee Vice Chancellor was sitting, Dr. D.V. Singh, and of course there was Dr. R.N. Iyengar from Indian Institute of Science, and Dr. Madhav from IIT Kanpur. All these people were sitting and they started shouting right at the other person who had come from IIT Bombay. Then because he could not give the proper answer for the things. But fortunately, I had worked on this area. And then when I just went there, they were totally convinced. And as the definition of composites, when I just told them, and how I have viewed concrete as a composite. Normally, civil engineers do not use the term composites for concrete. So I just used it because I had the great association with Dr. T.S. Nagaraj of Indian Institute of Science. And therefore, I could go for another domain also called controlled low strength materials, which I guided around 5 PhDs in this area. And of course, it's a beautiful thing that I will show you. Instead of telling, it's nothing but waste material gaskase paisa for a lower strength cementitious matrix material. So certain times you are seeing in the entire city, everyone is digging a huge trenches, correct? Huge trenches are being dug. See, what do you do that? So you again fill this with earth means it is nonsense. You should not do that because you have to really require a compaction effort for that. And to avoid all this, and what you could do is you could use a CLSM, which is nothing but a zero energy material, and it's having around water cement ratio up to 15. You can simply, keep on making it flow and fill the crevices, and then the cables could be just buried under that. And again here, there are two issues. So one is under the foundation for a structure, then it is non-diggable CLSM. If it is for a cable, then you may have to dig it again. Or if it is for a BWSSV pipe, you may have to dig it again. So in that case, you have to diggable CLSM. You have to design. So design of these things have to be done. It is not simply, without knowledge, you are doing all these things. You have to design the CLSM. How do you design this, say, starting from a 3.5 megapascal, so diggable CLSM, to a 8.5 megapascal non-diggable CLSM? There's going to be a lot of difference in this. And when you use this, all this entire zero energy material, what I discussed, could be used as repository in this. And you are now the dichotomous problems of the shortage of resource and also the pollution control, both will happen. And therefore, these are very two novel things where which I have worked myself for around 15 PhDs I have given under my guidance. And then the mixed design, of course, is not available. Let me clear it. And if somebody says mixed design is there, he's nonsense. So please note that you go for phenomenological models, right? And that's the only thing. And I don't have time to explain to you what is this Abraham's law and the Lice rule, etc. For the non-standard materials, you have to create it. So let me just show you, right, instead of talking all our research. So all our research, it ends with what is called a product. And please note that this is the finest example of University of Queensland's Global Change Institute, GCI, using geopolymer. There's no cement concrete has been used here. It's purely geopolymer. Geopolymer building is free, and this is really, it is called this thing. So depending on whether we are going carbon efficient buildings, so we classify these buildings as the platinum rated buildings and the gold rated buildings and the silver rated buildings. If it is a platinum rated building, so you get the tax holidays completely for 10 years or so. So if it's a gold rated, you may get a tax holiday for 5 years, no tax, etc. And in Gurgaon, Wipro has built the platinum rated building, so which earns 2 crores from its own energy saving. Energy saving itself is giving it, and it is completely. And also CLA building at Secunderabad is also a platinum rated building. And if you ask me, is there anything in Karnataka? Yes, we have one building in Karnataka, which is Syed Mohammad Beri Saab has built it. That is called the Berries Research Triangle in Whitefield, 2.5 acres. You can go through the thing there. You can, of course, it is a real worthy thing to just visit that place, right? We, the chemical engineers and civil engineers, should visit that place, Berries Research Triangle, where he has completely made use of this supplementary cementitious materials and also all these alternative technologies and made it. But please note that the cost of the flat is 30 crores, right, each. So that is not the thing. So please understand, it is not that the waste material is used, but the cost, it is a very posh building. You cannot simply, right, take it. Only COOs and CEOs can purchase here, right? Sorry for that, right? Please note that waste is not a waste. Waste creates a resource, and resource, of course, is costly, right? Please note that, therefore, don't call it a waste henceforth. So civil engineer will never call it a waste. You give us everything. We are the repositories in concrete. So we have got the best material called concrete, and we have also got water. So the civil engineers, two things that we deal with is water and concrete. Both of them, right, can hold waters. Yes, next is going to be, right, I told you this is about geopolymer. Geopolymer is 100% utilization of this supplementary. But whereas you come to the controlled low strength materials, you can just see how right it is there. You can say fill the trenches, etc., using this. Gaskase paisa huidang huita irbodu. So you can just like a porridge, porridge get type, you can just flow it into the trenches like this. And we have done it, and you can easily do this, and without any compacting effort, you can easily, do this without labor problem, any problem, right? You can fill the trenches. You can do all this within minutes, correct? You can just have the solution for it, and without having, I don't know why in Bangalore city for 3 months also or 4 months also they are not filling it, correct? They also fill it with earth. It's nonsense. I don't know who has to really teach them. When we have this technology, we can give the technology at BMS Engineering College or any other college, our college or any college, right? We have a lot of people. Dr. Ranganath is there, and Dr. Raghunath is there. So all these people, Dr. B.B. Ravishankar is there. So all of us can give us the solutions, right? The CLSM. And the sorry state of affairs is, if you go and ask a corporation engineer what is CLSM, he says, what is that? That is the sorry state of affairs. And now it is coming to the Agni Tattva, that is the fire resistant structure. So please note that the energy enshrined has to be handled properly with the planning and, of the structure itself, right? The planning. And the best planned structure hitherto in the world has been the Madurai Meenakshi temple for fire resistance. It gives you the number first rank. So I think one has to go and visit the Madurai Meenakshi temple for studying what is called the fire resistance. So you have to see the climatology, air circulatory blocks, the embodied energy, zero energy materials, and renewable energy. Soil stabilized blocks are not used. Of course, Laurie Baker technologies are not used. This is nothing to do with the Madurai temple I am talking. This is something different. I am talking about the Madurai Meenakshi temple where there is fire, but it could sustain it. There's a fire, it could sustain it. See how 2000 years the Madurai Meenakshi temple is there and is such a wonder, right? So that is the greatness of the Indian engineers. And why not today? Why not today? We are energy efficient. And of course, the fire resistant materials, of course, has to be all these things, blah, blah, have already told you. And the Larry Baker technologies, of course, I have told you, Larry Baker died 2 years back at the age of 100, right? And this thing. And the burning of the Mysore World Palace, all of us know that they burned, right? Right. And of course, the ATM also, right, got a fire and all these things. You have heard of it, but it could not sustain. So because it is a not sustainable, right, technologies, if you use, this is the nonsense, it will happen. It may be French or whatever it is. So another thing is the World Trade Center. Please note that the World Trade Center, right, the concept is it's 1930s. So we never had a technology, right, to have, or even today, right, we civil engineers, we do not actually, design a fire resist for fire because it will be too costly. So what we think is that fire is not going to be a problem for us, right? Somehow we can just put out the fire. That is the notion. And our code books, do not deal with the fire so much as the other aspects. And what happened in World Trade Center, please note that the energy, right, is required. See, even the World Trade Center, any kind of aeroplane comes and hits, right, it will not affect the World Trade Center. It is designed structurally like that. In 30s itself, structurally it is so sound that no aeroplane hit can, right, affect the structure. Then why did it fail? That Osama bin Laden was a civil engineer, unfortunately from Cornell University, where Ratan Tata studied in the same branch, architecture, structural engineering. So both of them are structural engineers, but of course, Ratan is a different man. And what happened here is, having known that Osama bin Laden knew that this energy, if it is created, you can create plastic hinges in the steel structure in the World Trade Centers. That he knew. And that is why what he took is the plane that is traveling from, right, flying from New York to California. It's a long route. So it had enough fuel to create the plastic hinges. So fuel has enough energy to create. So he just went there, right, and dashed against the structure, and then, of course, put it on fire. And when he put it on fire, then plastic hinge formation took place, and then the entire structure collapsed. So please note that this is not the correct way of dealing with the energy. So it is the misuse of energy, I can say. And the entire World Trade Center was gone, not because of any kind of a, right, the aeroplane hit, as it is wrongly understood. It is wrong, right? Please note that it is an energy that was created by the terrorist attack, right, which caused the plastic hinge in steel, and it just fell down, right, like the house of cards. Then I think we had to understand all this. And of course, coming to the Panchabhuta, like the Jalatattva, what happens here is that you please listen to it. I will just.
So the audio, I think, is not. They're not able to listen to the audio.
Uh-huh. No, if the audio is not there, let me explain to you, sir. Okay, that would be the best way. So please note that this water technology is correct. What about the energy? Correct, you are talking about. Earlier, from 1968, that Mogdum's period, we had the Kaveri treatment plant. Correct. So we used to go for what is called the clarifiers. That's the clarifiers, clarification, right, with coagulation and all these things. So used to go. And now, if you go to Thorekadnalli, you will see the Degramont plants. The Degramont, the French engineers, right, have created, and we are very happy to say that Bangalore city gets Kaveri water, and the Degramont plant is the first of its kind in Asia to be done in Thorakadnalli, that is for the Bangalore city. So please note that here we use a pulsator clarifier. It's a fantastic technology. See, the best way of handling energy, correct, and you don't have to create anything. You create a sludge blanket and through which, right, you allow the coagulated water, right, and please note that the pure water comes out the other way and the scum can be taken out on the other side. So it's a pulsator clarifier. So please note that these kind of technologies have a lot of saving on the waste materials and also on the energy side. So please note that conserving energy itself is very important, and that is what I have been professing always, right, as a civil engineer. So this is, of course, you can go and see in 60 kilometers from Bangalore, it's there, right, and you can go and see and take your students also. And of course, the next one is, right, I will not deal with this because Dr. Baswaya sir has enough dealt with, but I have to remind you that it's a compost, of course, is a soil conditioner, not much a fertilizer. See, please, it is misunderstood as a fertilizer. If somebody says it's a fertilizer, nonsense. So there's a low concentration of NPK and the high organic content is there. I'm talking about municipal solid waste, compost from MSW. Please note this. Do not have any kind of apprehension. Don't say it's cow dung or something. No, 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 no. I'm talking about MSW city waste, right? We have got the first-hand information on this, right? And simply, messing it with the cow dung and other thing is wrong, right? And we have got unused chemicals, research byproducts, batteries, used oil, spent solvent, and mercury recalcitrants and the benthic waste from Belantu tank also, right? We had the same problem. And my student only is now at IIT Kharagpur. He's doing his postdoctoral, fellow. He is right there. And he has worked on this. And of course, we did a 42-kilometer stretch of the survey, right, from Rajarajeshwari Nagar to the Bairamangala Reservoir. So for the first time, right, we were happy to take our findings to the High Court of Karnataka and we presented to the Chief Justice also, right? And we have a lot of things to say about the Vrushbhavati Valley. And right now we are also taking up the Vrushbhavati Valley, right? And of course we are from the judiciary also, right? We have got a kind of a thing, right? Help on this. And we got an 18 lakh rupees project on this. And I wanted to just say that this Vrushbhavati Valley project, I should thank Dr. Sampath Kumar. When I came to BMS College, sir, I am allotted this 18 lakh rupees project. What I should do? I don't have anything, which can do in a portable manner. In a portable analysis is not possible. Then at that time, nearly 1 crore rupees was given to BMS College, a laboratory, environment lab. And it was not right. I should not say it was not used, but I'm the only person which made use of that particular kind of equipment. And thanks to BMS Engineering College and also Dr. Sampath for such a gracious manner. He gave me all the things, and I have never seen a college giving because I was with RV College. So we were 22 students, and then we used 2 battalions of Madras Engineering Group, MEG Group, and to work on this particular project, that is Vrushbhavati Valley project. And we had to go to Bairamangala Reservoir where the sampling had to be done, and the samplers were taken again from BMS College, and all these things were done. And I have a report with me, so 400 pages report is there with me. And again, we are redoing it this time, right? And lots of things to say. And composting, I need not say because Dr. Baswaya sir has already told. And this is circuit economy. All people have talked, and Kuppekaran has got the best of its kind. Then if I keep on talking about this, this is first time my student, Mr. Durrani, right? He was the first person to lay a road called the Kempeg KH road, that is double road, using plastic waste. So he made a plastic as repository in that waste, and then after that he went to Dubai. He put a road there also, and he's my student at BE level. Then he went to MTech under Justo, And of course, right, name of Justo sir is also associated with that right now in the plastic road. So plastic road means a lot of things to say, I cannot just say. This is Badandur tank. My students, of course, have done along with right Indian Institute of Science, and he got a PhD in January 2020 with VTU, right? And when he was there as scientific assistant in the Indian Institute of Science, Mr. Vinay, so has worked extensively. And of course, a lot of benthic deposits are available. So the lot of energy is there at the NPK value. If you can recover this, the chemical engineers, so you have one more challenge. If the only chemical engineers can do this, and these benthic deposits, the NPK can be taken, you can be Atmanirbhar again. This is a challenge, I tell you. So it cannot be done by civil engineers. So civil engineers have a different kind of thing, and our brother chemical engineers have a different things to do, right? And I'm very happy that right, there is no more the head of the chemical engineering department, IIT Madras, Dr. Ananta Shastri, and myself, we worked with IIT Kanpur people, Dr. Agarwal in '84 on the fish kill episode at Grasim Industries, where I did the 42 kilometers survey of the river water, Tungabhadra river water from Irani to Mailara. So where the fish kill had happened. So I will talk about this, right, and right in the later stages, the pre-hydrosalite liquor. Dr. Puttaswamy sir knows it very well. So the Grasim, and my partner was Umesh, and who retired as vice president of the company. Rudy, yeah. So right now I'm talking about the same thing. So in, of course, this is a '84. There's what is called February. There was the biggest fish kill episode of the Asian region happened in Harihar polyfibers, right? That is Irani to Mailara. There was this thing. Mailara Jatra was there, and I was there working in the pollution control board as a temporary right assistant engineer. Then I was rushed by Captain Raja Rao to Harihar Polyfibers. Then I went there. And of course, Dr. C.A. Shastri, from the head of the chemical engineering department, IIT Madras, of course, joined with me. And we had a lot of studies there. And Hiremat sir was there. And Hiremat sir had challenged, he had come from Chicago to Madleri, his home village. And of course, we had a lot of this thing, right? And what was happening there, I tell you at the time, there were two things which happened. They had invested crores of rupees. I'm not talking that, they are not investing crores of rupees on treatment plant, but it was not working at all. Why it is not working? Please note that it was a food-rich waste. See, please note that, Ryan grade pulp industry is giving you food-rich waste. The food is right over-rich for the bacteria. But unfortunately, bacteria requires nutrients, otherwise it will not survive. So nutrients were absent in the waste, and they were having activated sludge process. How it could work? So please note that it could not work and it failed. Then hydraulic and general engineers, right, asked me, right, sir, it is not working. We have invested crores of rupees. Then we had to do a lot of activities there. And thanks to Dr. C.A. Shastri, sir, from chemical engineering department, and myself. So we worked on this, and we dosed like DAP and urea and all these things, and we could just rectify the thing. What's happening here, I tell you precisely, it's a very complicated thing. I tell you, it's not this easy. But however, it is my experience, and I have to tell you, eucalyptus tree, of course, comes from all over Karnataka, and then it is chipped over there in the chipper house. And of course, it's dried, and of course, in the digester, they add this sulfuric acid treatment and all that. And what happens is, in this gives out a very kind of two kinds of fibers. There is alpha cellulose and beta cellulose. What is required for the Grasim is alpha cellulose. There's love for alpha cellulose, I can say. And they take out the alpha cellulose, they just pulp it, and the pulp is bleached and of course taken to grasulin on the other side of the Tungabhadra river. And the grasulin, of course, is going to make it to fibers, and that fiber is taken to Nagda in Madhya Pradesh, the kingdom of Birlas, and there they make it into the suit lengths and pant lengths, etc. It is sold. So this is the fate of eucalyptus tree, becomes your pants and coats, and at a very costly kind of a thing. But what is happening to Tungabhadra River? Please note that you are taken out alpha cellulose. That is beautiful because it was a resource. But what about beta cellulose? It's a waste. It is not a resource they considered. So when we just examined this beta cellulose and other things, then it was coming out as a very hot liquid. It's a very highly thermally, thermal objection, right, by the Pollution Control Board was there, right? And then the pre-hydrolyzed liquor had a very high BOD. It used to be even 2 lakh BOD and 2 lakh TSS, like that, high temperature, acidity, etc. Is a lot of energy is stored in this. Then you're doing nothing about it. And what is happening is it directly goes into the Tungabhadra River. There's a lot of benthic deposit along 42 kilometers up to Mailara. And the Mailara Jatra, that people are wanted to take the holy bath. What happened is, I should not leak out certain of the information. It is very the governmental information. It came in the press, and what we did is a different thing. I should not leak it out. But anyway, we did a lot of intervention. Lot of fish died, and it came out. And in the fish market, it was available just 1 rupee per kg, like that. Then people were astonished. Such kind of good fish, how could they eat it? See, this entire pH liquor absorbed all the dissolved oxygen in the river, and then the fish died. And then thousands of fishes died, and then people started rejoicing, the fish eaters, of course. And the Jatra was closed because if somebody is taking a holy bath, his hair itself is coming out, because the pH liquor is sticking to his hair. So, and the benthic deposit is causing a lot of problems. So, and we had a lot of other stories to tell, because there's another 1 hour I required for doing this. And therefore, we suggested a system where this pH liquor could be converted into electricity. So anyway, that's a different story, right? And the other waste, of course, is also there. So from the bleaching waste and the other waste. And of course, those wastes are handled in what is called the anaerobic lagoons, and the other ones are handled in activated sludge process, ASP, right? And I don't have time to tell you about all this, right? This is about my plants, is my 1984 experience of the RAM grade pulp industry, right? And of course, this is the, right? Yeah, this is another experience of mine where I just worked for a brewery. I could have been a brewer in London, right? London Pilsner, London lagered beer, everything I can brew, correct? So right now there's a problem here, right? What's happening? The problem here is that the barley is germinated, and there's a particular length of barley only, is allowed to just go to the latter turn, and then the mash kettle, etc. And the wort is a decoction, very strong nutrient decoction, is high energy decoction. If anybody drinks it like a youth, he becomes very youthful. So please note that wort is going to be there, very good decoction. But what is happening to this? Because this barley that is germinated, etc., has got a lot of solid waste that is coming out of it, correct? Please note that the mash kettle, so you are getting it. So what I should do, say the barley solid waste, is getting into kind of thing. It was taken by the cattle breeders for the purpose of making beef, because milching cows they don't give, because milching cows become this thing, right? They want to increase the flesh in the cattle. So that is used for this. It's such a highly nutritious one. And this wanted to prevent this practice here, correct? And because 30 to 40% of energy needs of the brewery can come from this, because you can do it anaerobic digestion, and of course gas can be converted to electricity. So in the London brewery, also in Kuwait brewery, in Kuwait also they're taking out electricity from this waste. And of course this wort, of course, is coming, and yeast waste is another thing. So yeast is, of course, imported from other countries, and is the secret of the beer, correct? And one more thing is the hops. Hops is a dry flower from Kashmir or some Switzerland, and if you put the hops over here, it makes the beer the bitter. Bitter the beer, the better, right? So that is called, and therefore the hops flowers, right? That's also creating a lot of problem here. And yeast waste is coming, and of course you are joining it, and of course you are brewing it and all that. Then the decoction coming. This is green beer tank. This is unpasteurized. Please note that this is not pasteurized. And then again, the GBT to BBT, it comes the bright beer tank, and it's beautiful, right thing. And the beer comes. This is unpasteurized beer, and it's a highly nutritious one. And of course, right, it is not served in ordinary places except the 5 stars and the 7 stars unpasteurized. But to increase the shelf life of the beer, you have to do the pasteurization. And in the pasteurization plant, we had a lot of problems. So the bottles, were subjected to the hot water showers where it used to just burst out like anything, and the beer used to come out, and the beer, of course, is going to the drain, right? This is one area where the beer is going to the drain and causing around 700 milligram per liter of BOD. It was costing in the wastewater increase was that much. And also here, another problem was there, like the yeast waste, it was coming and joining directly into the drain. And suddenly, right, in activated sludge process, in the secondary settling tank, instead of the activated sludge settling, it is rising up, it is floating. Then we realized that what is it happening? Then when, just we examined that it was increasing the acidity, right, value in the secondary settling tanks, that is the type 2 settling was not happening, right, in the hydraulically speaking, because the yeast waste, created a havoc in a small dose. And therefore, we had to take it out and use it and give it to the Iyengar bakeries. The waste from the yeast waste used to give it to Iyengar bakery for making, and all these things are now yeast waste, correct? And the bottling plant, is another thing where you have this thing. And one more thing I just tell you, in the bright beer tank, the BBT, right, we were supposed to do one test. That is that if you gulp the beer, so nobody said drink the beer, you gulp the beer, so in the mouth, it should create enough pressure. That is the thing. See, there are two qualities. One is it should be bitter, and another thing is it should create pressure in the mouth. And that is because of carbon dioxide. And if it is not, then you are not supposed to enjoy it. So please note that this CO2 test was a mandatory thing at BBT. And when we did this BBT CO2 test using the galatometer, we had to, one test, we wasted 70 liters of beer. One single test, 70 liters of beer we had to waste. And it is getting into the wastewater drain. And then it is creating again a BOD, right? Creating increase in BOD and other things. So all these things, in an in-house plant, if you can keep your house clear and understand the system and understand the energy components in it, and probably, right, we can bring green energy. Green energy is what you save this bottling plant pasteurization waste, it becomes beer resource. And then you are saving on waste because it does not go into the drain. The simple things, BBT, you are using galatometer. Why do you use a galatometer and leave it to the drain? Galatometer say, give it back to the GBT. Then it's serving the purpose. Then what you're doing with the yeast waste? So yeast waste is let into this, and then in the secondary settling tank, then bulking of sludge is happening because it's an activated and live sludge, right? And the bulking sludge is totally defeating the settling process. And when it is doing that, then the yeast waste, of course, could be separated, segregated, and sold at a very high cost to the bakeries, correct? And right, and this could be the thing. And what you are doing with the barley solid waste, you are giving it to all this, beef cattle feeding. Why do you do that nonsense? Correct? It gives you 30 to 40% of the energy needs of the brewery itself. Please undergo the the procedures for the anaerobic digestion, like in London brewery, etc., or the Kuwait brewery, etc. You can get electricity of needs of 30 to 40% of the brewery from your own waste. And I think I have to thank Dr. Tippaswamy, who was my classmate there at the time, right, and right, who just introduced this brewery, Dr. Subrato Karyappa from Czechoslovakia, who was a fermentation, of course, food technologist. And please note that beer is not classified as a for chemical engineers. It is not, it's for food technologists. Beer is classified under food technology, not chemical technology. So please understand this. And distilleries are different, breweries are different, wineries are different. So the other aspect of the thing that I wanted to say is biogas from wastewater. So I had our good fortune with IIT Kanpur, the famous man, correct? So he had just developed a kind of a technique called the UFASBR technique. And this UFASBR technique, even at the AMC Engineering College, I have it. Right now we have this UFASBR technique. Anybody can come and see. We generate 1.5 cylinders of gas from around 140 kiloliters per day of wastewater that we have, 140 KLD wastewater we generate, and we don't have any solid waste problem, right? All the solid waste also, the organic waste is from the hostel is also digested, and also there is no nuisance, there is no smell nuisance, there is no problem of the sludge because we keep what is called the endogenous phase of respiration. You should understand the bacteria. Simply say that ನಾನು ಮಡಿಯಾಗಿರ್ತೀನಿ ಕೆಮಿಕಲ್ ಇಂಜಿನಿಯರ್ ಆಗಿರ್ತೀನಿ ಅಂದ್ರಾಗಲ್ಲ. You have to marry biotechnology also. You have to marry civil engineering also. This was I learned from Dr. Shastri from IIT Madras. So please note that you have to understand the bacteria, and please note that the sludge you have to keep it in rosa. What do you call the upavasa ಮಾಡಿಸ್ಬೇಕು ಬ್ಯಾಕ್ಟೀರಿಯಾಗೆ. Endogenous phase of respiration, you have to keep it. So what happens in that endogenous phase of respiration is that sludge formation is zero, minimal. All the things will become protoplasmic material, and the protoplasmic material will further escape right into the air as gases, correct? And of course, you can remove it, and there is no kind of ammonical component that is formulated, and there's no nuisance of smell also coming. It's a very decent kind of plant we have. You can see, I could not show the photo of that. And even the NAC people who came appreciated, and they gave 25 marks extra for us. And also the NBA people also appreciated. So they asked me right after going, they called me over phone and took 1 hour interview with me on this plant only, this NBA people, correct? So please note that this is a great technology which I have to explain for another 1 hour. It is not possible for me to right now do this, correct? And I can say Dr. Venkopachar is the first person from IIT Kanpur who emulgated this and who brought this technology to Trinidad City in West Indies. And Trinidad City was lit with light, generated from this plant. And of course, that is its own wastewater. Please note, your own wastewater, you can create electricity at BMS Engineering College. If you are not doing it, I'm surprised, correct? So please note that you can either use the right? Why only use gas? Please make it into electricity, right? And we have also been given 25 lakh rupees by Karnataka government, in 2000 itself, for a biomass plant at RV Engineering College. So when I was there, so we got 25 lakhs from the cradle, right? And they only installed the plant there, right? And a lot of things to say. It's a right. You have to understand the regimes and other things. And finally, I conclude by telling that
You're able to hear?
you are able to hear, sir?
Yeah, we just lost a second for few seconds. You can continue now.
No, is it you are hearing it?
Yeah, we are hearing it now.
A typical structure that we had to create for energy saving from the waste. Energy from the waste. Okay.
Sound is not clear, sir.
No audio.
Is there? Yeah, I will explain to you in 2 minutes. Just this computational fluid dynamics is required for this. Yes, life cycle analysis is being done. This is life cycle.
I think audio we are not able to hear, sir.
Yeah, it's okay. It's okay. CFC free air conditioning. We are just at the same. Zero use of CFC. This is for preventing global warming, right? By each house or each construction will have to take this kind of thing and renewable energy. On site. So Luxottica is using all non-polluting. Geothermal and wind technology, right? Of it's using it in Luxottica. Solar energy into electricity. You can convert. In our college, we have this. And we have a NEL sponsored program where we have the hybrid wind solar energy system. You can come and see it in AMC Engineering. And the green power is another thing. We have the first kind of a airport, the green airport is the Cochin airport, which uses the solar panels fully and create this. And the storage and collection, of course. Reduction of waste also is very important. To liquids, metals, and glass. Including glass, yeah. The regional materials, of course, 20 to 50% of the building materials can be manufactured within our campus itself. We can manufacture. That's what, and it will prevent the environmental impacts. Bamboo, right? Use of bamboo is going to be a very good thing, in a construction material, right? We can think of bamboo as an alternative material. Even bamboo reinforced concrete we can use. These are all certified. This is indoor and environmental quality also has to be monitored because that's also there. The OSHA ratings, right, will have to be natural ventilation, right? Natural ventilation should be. Urinals, these are urinals. These are urinals. Architectural elements, your department of architecture there in BMS college can take up all these things. They should have been here. Architecture department should have been right there. Yes. No, this chemical engineers will have to take care of this particular thing because the VOCs are coming out. indoor air quality is totally affected because of the VOCs in the structures, correct? Daylight should be utilized for the maximum. Yeah. 50% to 80% you can reduce. Like in the Bayes research triangle, you have the system. You can go and see in Whitefield. 50 to 80% you can. Maximum daylight and minimum. We can always make this BMS Engineering College the most energy efficient. That is what. Thank you. So it is ultimately leads to what is called sustainability. You have to develop, you have to engineer, you have to pollute, but control the pollution and have a circuitous economy. Thank you very much, Dr. Puttaswamy, for giving me this opportunity. I had lots and lots of things to share with you, but unfortunately, we don't have time. Thank you very much. Thank you, sir, for giving me such an opportunity. I am this is a wonderful kind of a disposition. Thank you.
I thank our today's speaker, Shashi Shankar sir, for giving such wonderful presentation on different aspects of energy aspects, and fundamentally is explained every portion of energy utilization from waste, not only from thermal power plants to fly ash and all those things. So I thank him for sharing his rich experience in vast consultancies that he has been carried out in different industries. If there is any questions, we will take it very quick questions of 2 or 3. I think there is one question. There is one question from TG Murli. Can you unmute yourself, sir?
Yeah, I am unmuted.
Okay.
Please tell me, sir. Please
I
tell
think
me.
there's a question from TG Murli, sir. He says that what is the composition of geopolymer, and what type of chemical bonding? What kind of chemical bonding is there in between?
Geopolymer, sir, right,
I'll take one.
geopolymer. It's a vast subject. I just say in one sentence, right? Further, I can share with our right experiences. It's just nothing but an alkali activated right fly ash, alkali activated fly ash, fine aggregate, coarse aggregate, and not cured by in
Yeah.
water, but it is air cured. It is air cured. It is air cured composite, correct?
Yeah.
And alkali activated, that is using sodium hydroxide. 5 molar, 6 molar, like that.
Any more questions from the participants? Okay. So I think there are no more questions, sir. Thank you. I think Professor C.T. Puttaswamy sir is busy with his other class. As you know that we are also taking our online classes. And
Yes.
so that is why he couldn't join for this session. So I thank again you for taking your time and uh, sharing your vast experience and everything. So thank you so much.
You can always, right? Feel free to.
Thank you so much.
Thank you very much. Yes.
I think participants, we can join for our afternoon session exactly at 2 p.m. So we have the session 3 today at 2 p.m. Okay, thank you.
Thank you very much, sir. Thank you.